Good morning everyone. My name is Shilpa and I am an assistant professor in Computer Science and Engineering Department working at World College of Technology and Management, Gurugram. Right? So today we are going to talk about advanced database system, in which we will be covering the three main topics of that subject. Like first we will study about the database management system, what the database management system is, why we are using the DBMS and what's its importance in our day-to-day life and in our career as well. Then we will be talking about the data modeling. So data modeling is what are the different types of models we are using in a database management system. Then we learn about the latest implementation in the field of database system. Right? So we will start with the first topic. So we will start with first we should know what exactly the DBMS is. Now, so first what exactly a database is. So what is a data? Data is an unorganized format of information. Like anything we write, pen, etc. Whatever we are writing over there is the data. Data means it is a raw facts and figures which has no explicit meaning. Right? So if we structured it or if we processed this data, this becomes the information. Right? If we write 10 kilometers, so this is representing the distance. So it becomes information. So in the DBMS, so information or data is used for decision making capabilities. Okay. So next is what the DBMS is. DBMS is a software which we use to store that data, and then using this stored data we can already insert an data, plus we can update the database, we can retrieve the database, or we can modify the data stored in this database. Right? So what are the advanced database system in it? To meet the today's requirement or to meet the today's organization's requirement, these are the various features which are implemented in the previous database. Right? So like first feature is the data modeling. As we all know, data modeling is creating data into different formats. Like we know the traditional database systems are like relational DBMS, and then we have ER diagram, and then we have network database models and hierarchical models. So nowadays, since due to the latest technological involvement, we have new data models, like we have relational data models, then we have distributed database, then we have object oriented database, parallel database we are using, which we will be learning in our next topic. Then it provides the different multimedia data types. It supports different types of data we can store in our database, like we can store images, we can store audio files, we can store video files as well. Then it has a new implementation of data integration, like we can integrate our database using into various technologies, like we can integrate it with the AI, we can integrate it with the machine learning. We have different fields as well in which we can integrate our database. Then it has a various query languages, like we know about the DDL commands, then we have the DCL commands, then we have the TCL commands, using which we can process our database using these query. Then we have some system features and the interfaces which we can connect our database with the outside world. So in the data modelings, we will be talking about distributed DBMS, we will be talking about parallel database, we can talk about object oriented database. So first we will start with the distributed DBMS. So as we all know that with the growth of globalization, with the federal environment of an organization and the web-based environment, so nowadays the data, the organizations, they have several units which are across the world. Right? For that purpose, the data is scattered to the various locations. So for that requirement, the organizations, they are lean towards the distributed database, where they have different organizations, structured unit, we have distributed database. So to connect that distributed database, we have the computer network. So this is an diagram of a distributed database where we have different sites. So these sites representing the different structural unit of an organization, and each organization have their dedicated database which are attached to that particular site. These database, these consist of the complete database of that particular site at whatever the remote location it is, right? But since they are representing the single organization, so these databases are required to be shared with the central unit. So we are using the computer network through which the distributed database, they are sharing their data with the other locations as well, right? So what exactly the features of database system is? It maintain the CRUD functions. So what is the CRUD functions? Like we all know that what database do, it create the database. So C stands for create, R stands for retrieve, U stands for update, and D stands for delete function. So the CRUD function is C create. That means we are creating the database, like we are creating these databases in using any data models, where we can use the relational data model, we can use the ER model to store that database. R stands for retrieve. The meaning of retrieve is to access the data from the database, where you can, using some query function, you can retrieve any kind of information from these databases. Then U stand for update. If we want to modify or change any kind sort of data, we can use the update functions, and if we want to delete any information, we can use delete function. So for these databases we use CRUD functions, right? So next, for the data updation, like since our data is distributed to the different locations, so the main problem which we are facing with the distribute is using the updation. Suppose if we want to update any data at the site number 3. So the problem we face is that this database, where the data is shared with other sites as well. So whenever we update the data, so that data is updated to the local sites only. So in the distributed database, the problem is solved using, so whatever database we are shared or the database is created, we generally update the database universally. So that is the responsibility of the distributed database to ensure that the data updation we are doing at any of the site, that updation should be done universally, so that there is the data consistency or the consistent property of database is maintained. So this property is ensured by the distributed DBMS, right? Also, since the database are stored at the different locations, so they can use various data platform. Like for example, we can use MySQL, or we can call it as a MySQL as well. So where data is updated using MySQL. Here we are using the Oracle. So if we are using the different data platform to perform the CRUD functions, so it is capable of handling the heterogeneous data as well. So whatever way we are using to store our database or the data we are sharing, it is capable of maintaining all the database with synchronization process, right? So this is a distributed database. So what we have learnt in a distributed database, in which the data is scattered to the different location, but still using the computer network we can share the data and we can perform all the information starting from the insertion, deletion, updation, modification. Plus the main problem was to maintain the data consistency, which is ensured by the distributed database, and it can perform various heterogeneous data operations as well, right? So next we will move to the next topic, which is parallel DBMS. After we have learned about the distributed DBMS, the next topic is parallel DBMS. So parallel DBMS uses the concept of parallelization. So what exactly the parallelization is? Parallelization is using multiple resources parallelly or multiple uses simultaneously. So the main feature of this DBMS is it uses the multiple resources, like we can have the multiple CPUs, we can use the multiple CPUs at same time, we can use the multiple disks simultaneously through which we are using the database. Plus the higher availability of the resources is also the one of the advanced feature of the parallel distributed, and then we have the performance measures of the parallel DBMS. Like since we know the workload is increasing, the amount of data is increasing day by day, and we require less time. So to effectively access the database, we must use such kind of structure which is parallelized, which we can use parallelly. So rather than the previous traditional systems like client server architecture or the centralized system, so we are using parallel database in which we are using multiple resources at same time. Suppose we have a CPU, we are using a CPU to process any query and it is taking 3-minute time to query that answer. Then we can use in parallelization, what we can use is we can use the multiple CPUs together, like we are using the 3 CPUs and we are dividing that complete task into the 3 portions and we are doing it simultaneously. So we can get the complete output within 1 minute. So using the parallelization or the parallel DBMS, what we are getting is we are getting the data effectively in lesser time, right? So the advantage of using the parallel DBMS is like if you want to measure the performance factors. So these two are the performance factor which we can measure for the parallel distribute DBMS. So one is the speed up. So speed up means it has the capability to process that query in a less time. How we can do that? We can do it, we can perform that operation using by increasing the number of resources, like we have done in this example. Like if we have the one CPU, the total time taken by that CPU is 3 minutes, but if we increase the resources, if we have increased the processor to 3 times, then it will, we are getting that answer, that query in 1 minute. So by increasing the resources, by increasing the CPU, we have decreased our response time. And if we talk about the graph we are getting for it, so if we look at the graph for the speed up, so these are the speed and then we are the resources. So what we get is, so this is the idle speed up curve we are getting, right? So as soon as we are increasing the resources, so this is the speed, or we can call it the response time. So first, what is response time? So the response time is the time taken by the processor as soon as we give the query and then we are getting the output. That complete time is calculated as response time. So as soon as we are increasing the number of resources as per our requirement, what we are getting improved response time. So this we can say is an idle speed up curve. If we increase the resources, we get our answers very quickly and effectively in lesser time. So another performance factor we can look is scale up. Scaling up, because scaling up means, now we all know that with the increasement of the data, like data is increasing day by day, but we have a large number, increasing workload, and then with increasing workload we can increase the resources as well. So if we look at the graph for the scaling up, so what graph we are getting for the corresponding response time and the resources, we are getting the parallel, and then this is an idle scale up. Sorry, this is an idle scale up graph. So as soon as the workload is increasing and we are checking the scaling up, so this is the graph we'll get for this performance factor, right? So this is the parallel database. Then one important advantage of parallel database is the parallel distribution with the structured unit, and it also uses the concept of OLAP and OLTP, right? So in the database, what we are doing, we have the structured unit. So what was the structured unit? Structured unit was a different database where the data is stored at the different locations, and we are using either parallel distribution in the parallel DBMS, or we can have the distributed distribution in the distributed DBMS. Also it uses the concept of OLAP and OLTP. So what exactly the OLAP and OLTP? So these are the concept of data warehouse. So data warehouse is what exactly the data warehouse is, where a large amount of data is stored, right? So OLAP stands for online analytical processing, and OLTP is online transaction processing. So like what is online analytical processing? Like OLAP we use analysis of data. That means we are doing data analysis. For example, like we are using YouTube, right? We use Netflix, we use Spotify to listen the song. So whenever you are using the YouTube or you are using the Netflix, so we are getting the movie recommendations. So movie recommendations are done using this data analysis. So from the large amount of data, we are getting some recommendations as per our interest. Also, if we listen the music at the Spotify, so whenever you are using different YouTube music or the Spotify or another any music streaming applications, what we get the personalized home pages, right, which is as per our interest, plus we can have the personalized playlist as well. So all this personalization is done as per our interest and our previous history we are using on that particular application. So with the help of online analytical processing, the data analysis is done and we get different recommendations as per our interest. And OLTP is online transaction processing. It increases, it ensures, it checks the online day-to-day transaction of our organizations, right? So these are the concepts we have learned about the distributed DBMS and the parallel DBMS. And we'll next move to the third section of this lecture, in which we'll be learning about the latest implementation of concept in DBMS field. So after we have learnt about the different data modelings in which parallel DBMS or distributed database we have learned. So what are the latest implementations which are being done in the field of advanced database system? Okay, so as we have learnt that it has the data integration capability, like we learnt about initial of the lecture, like it has a data integration property, which means it can be integrated with different concept as well. Like if we talk about the data artificial intelligence, so what exactly the artificial intelligence is, कि using some machine or some algorithm we can make some decisions, right? So artificial intelligence, with the help of artificial intelligence which is integrated with the DBMS, so we can schedule our routine task. For example, we can optimize the database. So database optimization is one of the process which we can be used, which we can done with AI. And then tuning. So what is database optimizations? Like we know we have a large amount of data stored in the database. So to process that database or to retrieve that data from the database, we perform queries, right? We perform operations. So various operations we are performing, so they should be performed in a very simple manner with effectively and with less time. For that we require optimization of database, which can be done with the help of different artificial intelligence algorithms, right? So we talk about the data analysis. Like what data analysis we do is we perform various functions like as per our recommendations, like we have just learned about the YouTube movie recommendations, then Spotify personalized homepage or date playlist. So what we use data analysis. So with the all different users, the data is analyzed with the help of these algorithms and we can perform the operations performed. Also we can implement the database in the using some machine learning algorithms, like we have various drawbacks. We have some performance bottleneck of the database, like we studied about the speed up capability of a parallel database, and then we have the scaling up property. So there are still some performance bottleneck which can be removed with the help of machine learning algorithms. We can also perform query optimization. So what the query optimization is, to access to retrieve the data from the database, we perform query. So to optimize these query we can use machine learning algorithms, right? So also we can have the use of blockchain technology. Like nowadays this is one of the important concept we are using. So what the blockchain technology is, the blockchain technology help to improve a new secure system. So as we all know, we store our database, like we have our documents, we have our images, we have videos which we store in our database. So we have the different crucial data for the organizations, we store that in the database. So to provide a more secure or the tamper resistant environment, we use the blockchain technology. Also there are many concepts, like we are talking about edge computing. We are implementing this on our latest, and then we can have graph based database. So these are the few concept which we are getting in our, which we will be doing in our coming days. So these are the few latest implementation which are done in the database fields, right? So students, we have learned a few topic through which we learned what exactly the database is, what's its importance, like why we are using the advanced database system, what is the requirement of advanced database system in our recent time. And then we talk about different models, like we learned about the parallel DBMS, then we learned about the distributed DBMS and what are its advantages and what are the features, and lastly we talk about some latest implementation or the integration of database with different technologies. So with this we will wind up the lecture. Thank you.